Suppose you have to push a car to start it. How will the amount of force you apply to it affect how fast it moves? What if you have to push two different cars? One that is heavier and another that is lighter. Which one do you think will move faster or slower? These questions can be answered by the second law of motion of Sir Isaac Newton. It states that the acceleration of an object is directly proportional to the force acting on it and is inversely proportional to its mass.
In other words, the more you push a car, the faster it will move or accelerate. Other examples where more force equals more acceleration, a throw of the ball gets it farther than the pass of the ball. The harder you bat a baseball, the farther it goes. The more powerful the engine of your vehicle, the faster you can drive.
That's for the first part of the second law. How about for the last bit? It is inversely proportional to its mass.
Well, let's go back to the car example. If you apply the same force of push to two cars which are different in mass, the lighter one will move faster compared to the heavier one. More force is needed to move heavier objects compared to lighter objects. Examples of these can be seen in moving furniture at home. Heavier objects are much harder to push around. Loaded cars need more force from the engine compared to empty ones.
We've described the second law in terms of its observable effects, but how do you translate it into numbers? Mathematics, after all, is the language of physics.
The second law of motion can be written in the formula F equals m times a, where F is the force acting on the object in newtons, m is the mass of the object in kilograms, and a is the acceleration in meter per second squared of the object resulting from the applied force.
To prove our point that more force equals more acceleration and more mass equals less acceleration, let's try to solve for acceleration using small numbers for now. But how do we solve for acceleration if the formula is F equals m times a?
We can use this triangle to help us derive the formula for the quantity we need to solve for. You only have to cover up the variable or quantity you want to solve for. In this case, a equals F divided by m. For example, we have a force that is equal to 2 newtons and the mass of the object is 1 kilogram. The acceleration of the object is 2 meters per second squared. If we double the force while keeping the mass the same, the acceleration also doubles. Now for the mass. Say we have 2 newtons of force and 1 kilogram of mass. We know the acceleration is 2 meters per second squared. If we double the mass of the object while keeping the force the same, the acceleration halves. If you are wondering, why is the unit for acceleration meter per second squared when there is no meter or second in newtons and kilograms? Here's why. Newton is equal to kilogram times meter per second squared. Divide it with kilogram and it cancels, leaving meter per second squared as the unit for acceleration.
To summarize the lesson, remember this triangle to keep in mind the relationship between force, acceleration, and mass, or simply the second law of motion.